Welcome to qnawire.
Here we're given an interesting device with some kind of mechanism on it so that point A is free to slide within this other device that also rotates. That's device D. Point O is hinged, point C is on a hinge, and B is free to rotate then. We're given some lengths such that the length OA is 0.16 meters. The distance OC is 0.08 meters, and the height between A and F or E and F is also 0.08 meters. And we'll have to use some geometry and trigonometry to figure out some angles and then figure out how fast that latching mechanism AOB actually rotates. So first, we'd like to find this angle theta. So over here. So we can do that by looking at the sine of this right triangle EFO. So the sine of that theta should let us find theta as the inverse sine of the opposite side. So that's EF, which is 0.08 meters, divided by the hypotenuse, which is 0.16. The inverse sine of a half gives us 30 degrees. We can then find what this distance CF is by looking at this as a right triangle here. If we look at it as the length of the hypotenuse squared, OA squared, equals the length of the base squared, which will be OC plus CF squared, and then plus the height squared, which is just that EF squared. When we solve all this for CF, just using algebra here, we should get about 0.0586 meters. We can then find this angle beta here. So beta we can find by taking an inverse tangent, since we know what CF is and we know what EF is. Take the inverse tangent of that 0.08 divided by 0.0586, and we get about 53.8 degrees. And there are a couple more quick angles to look at here. We know that this angle up top here, let me make sure I get the right angle for a second here. So we want to look at the difference between beta and theta. So beta minus theta will just be the 53.8 minus 30, so that gives us 22.8 degrees. And we'll also need to find one more angle here. And I should point out that the reason we're finding these extra angles here is when we look at a velocity diagram that I'm going to try to leave everything else on the screen here. But this velocity diagram will have the velocity of point E, which will be down and to the right. We'll have the velocity of point A, which will just be at an angle down. And then we'll have the velocity, let me redraw that one, that's off the mark. The velocity of A with respect to E, which will be to the left. So this is VA with respect to E, VE, and VA. So where these angles come in is that we have our angle theta here. We have our angle beta there. We have an angle to the right here, which is 90 minus beta. And we have an angle of 60 degrees over here on the left, and gamma on the right here. So that means gamma is 120 degrees. And I wrote this beta minus theta wrong. That should be 23.8 degrees. Okay. So one other thing I haven't found yet is the length EC. And EC is just this length right here. So we can find that by just looking at the sine of that angle beta and comparing it to the height. So length EC here should be 0.08 meters divided by the sine of beta, which is the 53.8 degrees. And if we put that in, we get about 0.0991 meters. So the next thing we can do is write an equation relating the velocities A and E. So we have VA equals VE plus VA with respect to E. We can say that the velocity VE equals the length EC times its angular velocity omega EC, which should give us about 0.149 meters per second. We can then use the sine rule to find VA. So if we use the sine rule, we have VA over the opposite angle, which will be that 90 minus beta. Sine of 90 minus beta will equal VE over its opposite angle, which is sine of gamma, which leads to VA equals 0.101 meters per second. We can then figure out what the velocity or what the angular velocity of this section AOB is by looking at VA. We know that omega AOB should equal the velocity of A divided by the length OA. So that would be 0.101 divided by 0.16, which would give us about 0.634 radians per second. And we need to figure out which direction this would be moving in. So I'm going to scroll back up to the diagram a little bit. If A is moving to the right, that means this entire thing should be rotating in the clockwise direction.